Hello everyone, my name is Avkash and you are welcome to another tutorial where we are going to use matplotlib library to perform the data visualization in a 3D graph. 3D graphs are very useful to see the three different values on x, y and z axis, and we can understand the relationship between these three values in a 3D plane. This way, the information in our data set can be visualized very well and can also be understood very well. The very first example, I have to show you the Superbowl ratings and the total TV viewership per year. And in these images, you could see how the values from every year TV viewership and the Super Bowl rating is visualized through 3D graphs. The next example is related with supermarket sales data, where depending on the sales of certain products in certain city and the total number of sales are visualized through different visualization examples. And then finally, a very popular Titanic dataset is used to visualize the 3D graphs combining the three different columns from the Titanic dataset. Here we are using age, fare, and the survival rate, or the age, fare, as well as the cabins where these Titanic passengers were traveling. The objective for us in this tutorial is to learn how to build these 3D bar graphs and create a common used function which can be used anywhere wherever you would want to use this function, and just by passing your data frame and the selected columns you would want to create the 3D graph. So let's get started. The data set used in these tutorials are already available here, which you could get directly. So in this tutorial, we are going to use the matplotlib, and here is the 3D version of matplotlib library, which you could also use depending on your need. So please review these libraries for more details. The Jupyter notebooks, which we are going to use in this tutorial, are also available at public code GitHub repo. Finally, as you could see that we do have all the Jupyter notebooks up and running. Very first, I will just try to run very quickly and see the results. Here I have imported all the required libraries, and very quickly I will be loading this file. And here I already have Super Bowl ratings dataset, which I have gleaned through from this URL. So that data frame is available in the memory, and using this function which we have loaded from this Python file, which is available at the same location where these Jupyter notebooks are, I am creating this 3D plot using the year, TV viewers in million, and the overall rating. And our title for this graph is Super Bowl ratings, viewership, and color is red. As you could see here very quickly that this is the TV viewership in the million, and here is the year, and here is the overall rating. So the 0 rating and then the highest available rating is really extrapolated based on the ratings value from here. So the lowest value is considered as a 0, and then from lowest to highest the margins are being calculated, and that is what being rendered on this Z graph. So as you could see here that this is your TV viewers, which is X, and your Y is year, and then rest is all implemented here. If you want to switch between X and Y, and here is a different way to look into. So here you could see that depending on which year to oldest to latest, viewership from lower to higher, and here's the ratings. So the 2010, the viewership was really very high, 110 million, and the rating was calculated really very high here. As you could see here, when we are trying to calculate, same thing is the viewership is here and year, and it's a different way to see those results. So how this whole code was being created. So that's the part of this tutorial. Let's take another example. Here we are importing the required libraries matplotlib and matplot3d, and we are using the axis 3d module here. We are importing this function. I will be talking more about it. Now we are importing the supermarket sales data set. Here is our supermarket data set. As you could see that here is like there is an invoice ID about 1000 rows, and depending on for which city, what type of consumer, and the type of gender, the consumer gender, there is a product line, and then the unit price, quantity, tax, total, and then what was the type of payment, was the COGS, gross margin, and rating. All that information is available. So if you want to build the 3D plot using XYZ, as you could see here, we are building a 3D plot where you could see that COGS is here. Here you could see the gross margin percentage, and it looks like it's a constant percent here to there, and then here you could see the gross income. So if we build something like that way, it doesn't make too much sense. But if we try to change this to a little more different, now you could see that depending on ratings, so we are using ratings, and here is the cost of goods, and then finally we have gross income. So same is a supermarket sales data. Color it changed. Here we are using another view where the total, tax, and then unit price. So depending on a unit price and the tax, how it is, and the total number of items. So as you could see here, there is a pattern is really coming into, as we are taxes is low, total is less, and the unit price is higher. But as we grow higher and higher and higher, the number of items is growing, but the taxes are also growing, and then the unit price is differently. So those views, depending on what your data set is, you can generate. And here you could see that we are using another view to look into the same information and in total different way. So how you could build these beautiful informative 3D graphs using X, Y, and Z columns from your data set. So here is the function. It's called generate 3D plot, and here we are passing the data frame, and then we are passing the three different columns which we need, and then our heading. And these columns will become the X, Y, Z labels here. Everything is between here, and finally that's what we are doing in this whole exercise. There is one more example I wanted to show you, which is here, and which is related with the Titanic data set. So we are importing the Titanic data set. Here is our data set look like, the number of unique items in each columns, and then it just shows the bar graph based on cardinality. So here it shows that depending on each columns, what the number of what the cardinality for each column. So this means that if you have 891 rows, the name and the passenger IDs are unique here. Rest, there is a possible that multiple people are traveling on the same ticket ID. That's why this is there. Fare is also in some groups. So as we are looking into this, you could see that the cardinality for the survived is 2, whether they survived or they not survived. Same thing, sex. So that's how you could figure it out, the cardinality, and then depending on the cardinality, you can say, okay, I would like to have a graph between X, Y, and Z. So here the age, fare, and survived columns are selected from the data frame, and this code has taken directly from this source code Kaggle here. So please go ahead and review this code. So this whole code is being taken from there, and then if we try to build this result, as you could see here, that's the cardinality. So here you could see that this is the fare, lower fare is there, and higher fare is keep coming here, and then here you could see age, that between 20 to 30 age, some of the people have paid highest fare at that. It shows number of passenger count. Here you could see that there are very few passengers here, but the between age group from 20 to 50 and the lower fare range, as you could see here, there is a very high passenger count, and if we try to look into that way, we could see that okay, this is how it looks like that in highest passenger were in that group. Now what we have done is that we have taken this same code, converted it into a function, and then used that function to render the graph. And here you could see that same thing we have called age fare survived. Here we have switched the survived age and then we moved the fare. So survived has two values, either they survived or they are not survived. So that's why you see that it took the two cardinality and tried to distribute across percentage here. So maybe survived is not a good option here to use, because we have to have the columns which really have numeric values to plot your graph better. So that's the reason I have showed that you have to select better columns in order to get better and distinct result what you want to see. If we take the same graph and we try to switch it with we say let's use age fare, and then rather than survived I wanted to use age fare and cabin. Yeah, now you could see here it just shows you that passenger count in which age and which fare. So actually the passenger count is not a correct heading here. So here we are saying is that so cabins have their cardinality. So we have looked into that, and this is how you could understand that okay, depending on higher fare, the different grouping versus the lower fare, the grouping is different. So that's how you can visualize the Titanic data set. And here once again I am using a pre-built function which I have got from this Kaggle exercise. So please review their code. I'm just using their code as it is in this example. Actually Z label should be code 3 here. So there was a little tweak needed in order to make this function. So I have just taken this function and tried to adjust it a little to make sure that everything looks good. Okay, so we have seen three different examples. We have seen Superbowl rating, it's also using the same function. So what I have done here is a little different. I have saved the function in this local file. As you could see here, the code look like that way. We are importing the matplotlib and pandas modules here and just creating a 3D plot function in this function. There is another way you could load this code, and here is the way, because you just need to load this file and then this whole file will be available for you to not only view the code but also to edit in real time. If you want to make a change, you could make a change directly here. And then next we are just using this function and then we are processing the result. So if you could see here that we are plotting this graph, that is our graph. If we want to change the color, we could say red. Now we want to say we want to make it blue, and the graph will be blue. However, if you want to make changes in this code here, 5, so let me make 5 here. There you go. As you could see here, that width is being changed depending on how you want to set it. So this would be the correct one, and this would be the 2, and that would be 3. At least 3. So these are the parameters you could change. So this way you have understood that how you could take a particular file and you could change it. Now we will learn how to implement this code from scratch all the way to the end. So this will be our whole exercise, and once you learn this thing, then it would be easier for you to understand the implementation of this function which we have used here. So let's come back to this Jupyter notebook and implement the code. First thing, importing the modules. Second, we are importing the data frame. So here this is our supermarket data frame. Everything we have already looked earlier, everything look like here. As you could see here, this function gives the number of units. So as you could see here that there are 1000 rows. It means invoice is unique for every record, which is very easy to understand. Unit price, if you could see here, these are the different values, but as you could see here that the cardinality is showing that how many unique values are in each column. Now what we are trying to do is that we are trying to select a few columns from this. So here you could see that for the city and the product line, and that's the total. So for this city, 1000 rows, these are the products are being sold, and this is the total for that city. If we try to group by this data frame for the city, as you could see here, there are 332 records for Mandalay, and then for 328 for this city and 340 for this city. If we try to use the product line, as you could see that there are 6 categories, and out of 1000 record, that's the distribution of these sales happen. If you want to combine these two, you would want to know for each city for which product what was the sale, and here you are going to get that result stored in this. So here you could see that depending on 6 product and 3 city, this is the total look like. So total there will be 6 3s are 18. So 18 records are there for city, product line, and total. Next, what we want to do is that we want to take this data frame which we have just created and we want to pivot it. So once we pivot it, now you could see here that this is what is happening. We have taken the same data frame, selected 3 columns from there, and now you could see that based on product line, so this is our 6 columns of product line, we are selecting the city. So this is our city. So this city column has taken as an index, and for Mandalay, for each city, this is the total. So what you were seeing here, it was a flat data frame. Here you could see that each column of product line, each item from the product line column has become a column itself. As you could see here, this is a multi-index frame. It means that for each value, there is a total of electronic accessories, total of fashion accessories, total of food and beverage. So this is a multi-index column. It means that we have to calculate this little differently. So as you could see here, when we were pivoting, we pivot for city was index, and the product line column where became all the columns. Every value in product line became the column. Now we will try to expand this. We will say, hey, let's use the values as a total column. Now you would see there the data frame, which the pivoted data frame is a little different now. And how we will know, as you could see here, now the values became little different, because initially when we did not use the values, total values, we got a multi-index column. Here we got a columns, but as you could see here, that column has the product line which is being used, all these items from there. So the product line columns items are the column names here. Values, as you could see here, these are the values. For each row, there is a value. Now, what we are trying to do is that we are doing exact same thing here. As you could see here, index is city, columns is product value, but we are resetting the index. So we could get a data frame little differently. And as you could see here, the product line, the index is created, and for city, and then the accessory is here. So what are the values? For Mandalay, these are the values. As you could see here, 2 columns, 1, and then rest is all here. For this city, these are the values, depending on these product line items. If you look into the columns, it has a city and then rest for the product line. So now what we are trying to do, we are taking this data frame and selecting only few columns, means from city all the way to the sports and travel. Now what will be the DFX look like here? As you could see here, is exact same data frame. There is not really much changes here. We are setting the index, so this product line is gone, and then city became itself the index. So now city is here. Okay, if we can still get the values, so it's still a working data frame. If you look into the values, values are here, columns are still there. We will reset, and now we have done is that we took this thing and then we say, okay, drop reset index, drop true and in place, and now you will see here that this index which was here has been removed, and product line These are the columns. Now, what we are trying to do here is that, as you could see at this point, we are renaming the axis, and city is here, rest of the column data is there, and the name for the index is no longer exist. So what we have done is that we just wanted to extract only these values and get the cities values, and then we just really need only this data frame. So we could get those cities only accessible to us as a row items. So what we have done, we have collected the rows and then removed the city, and then now we have a data frame which does not have the cities in it. As you could see here, now we got all the column values here. So here are the columns we have, and here are the values. As you could see here, that all the values are available here, and taking dfx values, there is no null values are there, so it's just a cleaning up the data. As you could see here, that the df1, which is number of columns, 6 columns, number of rows, 3 rows, and then if we try to flatten this df1, everything became a one big list item rather than having this a multi-dimensional array 3 of 6. Once we have got this thing, as you could see here, we are going to build this 3D graph using this code, and here we are creating the plot. It should be using the axis 3D, taking the data frame, get its length, that will be the total number of columns, that will be the total number of rows, and then we are trying to just set up the x position, y position, and the z position is also going to be calculated based on total number of items. So 3 times 6, 18. Then all these values are really being filled, and then the data frame is flattened. So that's where the DC, and then because we have 6 item here, so we are creating this 6 colors for that. Once we have got everything ready, now we are ready to plot our graph here. As you could see, that this is our title. We have already XYZ labels. We have put all these values, and here you could see that X, we have the product line, Y, we have the city, and then Z, we have the total number of sale. Same thing converted into the function, and now we are using that function to pass X, Y, Z graph columns, and then whatever our header should be. Here we don't want to see these warnings, so disabling the warning and then creating the graph depending on how you want to skew your X and Y. So same code which we have studied here to make graph, we went through in this Jupyter notebook and we digged into more so that we could understand how this graph can be created. So you could use either this function or you could use either this function, and you can plot the XYZ column based 3D graph. Here, if we try to understand the code, you are going to see is that whole data frame is being given for this function, used which column you would want to create the 3D graph. As you could see here, a data frame is created based on selected columns, and then all the null values or empty values are removed. After that, the group by function is used for column 1 and column 2, and then column 3 separately, and then it was counted based on that. And after that, all the values are used, and then rest, as you could see here, that we are just trying to use the numpy array so that we can fill those values depending on where they really come in this plot. The most of the things what we are seeing in this function, we have already seen here, that how we went through, how we selected the columns, as you could see here, and then what we have done, count or apply sum, depending on here you see that we are applying the sum of the values, but it's a similar function here. So that's all we had in this tutorial for you to go through with these Jupyter notebooks and take the code and optimize and modify it depending on your need, and use this in your data visualization project. In this tutorial, we have learned how you could use matplotlib, pandas, numpy modules in Python to build the 3D bar graph. We walk through the whole code, how a data set can be ingested, and 3 columns are selected to create your 3D bar graph. Finally, we created a function which can be used to render the bar graph wherever it is needed, so that you can render your data in much more informative way using these 3D bar graph visualization. That's all, my friends. I hope to see you in my next video. If you have enjoyed our content, please like it, share it, and subscribe it. At last, please be good and do good. Thank you.